flying at an indicated altitude of 16,000 feet. The outside temperature is -30. What's the true altitude? So indicated altitude means altitude indicated by your altimeter is 16,000. Outside air temperature is given to you. What is true altitude? Now remember, whenever you are flying from a high pressure area to low pressure area, the altimeter will overread. Similarly, when you fly from uh, this uh, warm air temperature region to a cold temperature, cold air mass, again the altimeter will tend to overread. Meaning, so you're flying from high pressure area to low pressure area, the altimeter will overread. Overread meaning the indicated altitude, the altitude indicated by your altimeter will be more than your true altitude. You are actually flying, meaning you're actually flying at 15,000 feet, let's say, but the altimeter will show that you are flying at 16,000 feet, 17,000 feet, 20,000 feet, any value more than 15,000. So you're flying under false delusion that false delusion you're flying at 20,000 feet when in reality you're actually flying at much lower altitude, 15,000 feet, 14,000 feet, whatever. So high to low, high pressure area to low pressure area, altimeter overreads, meaning the true altitude of your aircraft, the real altitude, true altitude of your aircraft will be less than the indicated altitude. Tachanantar, what's next? When you're flying from for example, warm temperature air mass to cold temperature air mass, again, the altimeter will overread, meaning the true altitude of your aircraft will be less than the indicated altitude. Now, what is the solution? Always when you are flying from one area to another area, reset your altimeters. Okay, set the current QNH that is available in that area in order to avoid this altimetry errors. So now, in this question, your indicated altitude is 16,000 feet. Outside air temperature is -30 degrees Celsius. So, our step number one will be to determine whether the outside air temperature is colder than ISA, or warmer than ISA. If it is colder than ISA, then we will have this result. What will be the end result? The true altitude will be less than indicated altitude. If this outside air temperature is warmer than ISA temperature, the true altitude will be more than indicated altitude. So step one, ISA temperature at 16,000 feet will be equal to 15 degrees Celsius minus 2 into altitude 16,000. So 15 minus 32 is minus 17 degree Celsius. So this is what ISA states. ISA demands that temperature at 16,000 feet be minus 17 degrees Celsius. What is the actual outside air temperature? It is minus 30 degrees Celsius. Now we all know minus 30 degrees Celsius is colder than minus 17 degrees Celsius, right? That means at this altitude, at 16,000 feet where you're flying, or the indication that you're getting, at that altitude the temperature is much colder than ISA temperature. Now how much colder? We will have to find out ISA deviation. ISA deviation equals to outside air temperature minus ISA temperature. So outside air temperature minus 30 degrees Celsius minus of minus 17. So minus 30 plus 17 is equal to what? Minus 13. So that means outside air temperature is colder than ISA by minus 13 degrees Celsius. Step number two, we all know since it is colder than the ISA temperature, true altitude will be less than indicated altitude, right? Now we have to find out by what value will be true altitude less than indicated altitude. Right now, indicated altitude is 16,000 feet. Now we have to find that value by which this true altitude will be less than the indicated altitude. What is how to find that value? Use this formula. Temperature correction error equals to 4 multiplied by ISA deviation multiplied by per thousand feet. Okay. So 4 into ISA deviation is minus 13 and indicated altitude is 16,000 feet. So multiply by 16. So 4 into 13 into 16 is 832 minus 832. So true altitude will be next step, step number 3. True altitude will be indicated altitude minus this temperature correction. Okay. So indicated altitude 16,000 minus 832. So 16,000 minus 832 is 15,168 feet. So your aircraft's true altitude is 15,168 and the altitude shown to you, the erroneous altitude shown to you is equal to 16,000 feet, a difference of 830 feet approximately. So the closest option here is 16,200, 15,000, 18,000, 15,200. Option Bravo. 15,168 has been rounded off to 15,200. Next. What is the task when pressure altitude is so and so, outside temperature is so and so, calibrated airspeed is so and so? Let's use CX-3. So go to airspeed, outside air temperature in Fahrenheit. Convert this into Celsius. Press the convert unit button and so outside air temperature minus 15. So write 15 and then press this plus minus button to insert the value, the minus sign. Gas 190, 145 and 15,000. So 145, 15,000. Check the values. Pressure altitude 15,000. Calibrated airspeed 145. Outside air temperature minus 15. So true airspeed is 182, approximately 182 knots. So option Charlie. Okay. Next, question 3. What is the true airspeed when pressure altitude is given to you? Outside air temperature and CAS. Similar to the previous question. Now, outside air temperature here is minus 20. CAS 220,000. So 20,000 feet, 200 CAS. Outside air temperature minus 20. True airspeed is 273 knots. 273. So option Bravo. 4. Velocity of the speed of sound at sea level in the standard atmosphere is what? So, velocity of the speed of sound is 39.17 square root of temperature in Kelvin. So, 39.17 square root of temperature. At sea level, ISA, sea level temperature in ISA is 15 degrees Celsius. So, 15 degrees Celsius plus 273 will be equal to 273 plus 15 is 288 Kelvin. Okay, so 288 Kelvin at sea level. So square root of 288 into 39.17. 664.7 or 665 knots. So the closest answer is 665, option Charlie. Next. If outside air temperature at 35,000 is minus 40, what is the local speed of sound? So local speed of sound equals to 39.17 square root of temperature in Kelvin. So 39.17 temperature. What is temperature? Outside temperature is minus 40 degrees Celsius plus 273. So that is 233 Kelvin. 233 Kelvin. So square root of 233 into 39.17 is 597.9 or 598 knots. So option Charlie. Question 7. Aircraft is flying at 310 knots to airspeed, 29,000 feet, temperature deviation -6. What is the local speed of sound? Now local speed of sound again is 39.17 square root of outside air temperature in Kelvin, right? So we do not know the outside air temperature. What we do know, ISA deviation equals to outside air temperature minus ISA temperature. So -6 equals to outside air temperature minus ISA. What is ISA temperature at 29,000 feet? 15 degrees Celsius minus 2 into 29. 15 minus 2 into 29, 58, which is minus 43 degrees Celsius. Therefore, outside air temperature equals to -6 minus 43. So -6 minus 43 is -49. That means outside air temperature at 29,000 feet is -49 degree Celsius. Substitute the values 39.17 square root of temperature -49 degrees Celsius plus 273 is 224 Kelvin. So 224. Square root of 224 into 39.17 is 586 knots. So correct answer here is 586. So option B, the closest. Aircraft is flying at flight level 310, calibrated airspeed 280, corrected outside air temperature -48. This will give a Mach number of what? So Mach number equals to true airspeed divided by local speed of sound. Now what is local speed of sound? It's nothing but 39.17 square root of outside temperature in Kelvin. Now let's find true airspeed. Let's find outside air temperature. True airspeed is what? So gas is 280, 310, 1000, 280. Corrected outside air temperature. Correct outside air temperature. -48. -48, 280 knots gas, 31,000 feet. Uh, Mach number 0.757 and true airspeed 443. 0.757. So what is the Mach number? 0.757. 0.75. The closest option is 0.757, so 0.76. Okay. So next. Question number 9. The temperature at airport is 23. What is the local speed of sound? So again, local speed of sound equals to 39.17 square root of outside air temperature in Kelvin. So 39.17 outside air temperature 23 plus 273, 296. 73.9 or 674 knots. So correct answer here is option Charlie. Okay, 674. So Charlie. Question number 10. Aircraft is flying at 1100 knots to airspeed, flight level 650. A change of 0.1 Mach gives a change of 57 knot TAS. The temperature deviation at flight level 650, assuming ISA, is what? So ISA deviation equals to outside temperature minus ISA temperature. Now we all know ISA temperature above flight level P60 or above 36,000 feet stays constant, minus 56.5 degrees Celsius. We are flying at flight level 650 or 65,000 feet. So the temperature there will be, ISA temperature at that level will be minus 56.5. Let's find out the the current outside air temperature, ambient temperature. So Mach number equals to 2 airspeed divided by local speed of sound. Now a 0.1 Mach number change equals to a TAS change of 57 knots divided by local speed of sound. So local speed of sound is 57 divided by 0.1, which is 570 knots, right? Now what is local speed of sound? Nothing but 39.17 square root of temperature. The square root of temperature equals to 570 divided by 39.17, 14.55. Okay, square that, 211.7 or 212 kelvins. Okay, so temperature is 212 kelvins. Now 212 kelvins minus 273 is minus 61 degree Celsius. So minus 61 plus 56.5 is minus 5 degrees Celsius. So option alpha. Question 11. Aircraft is flying at 29,500 knots as 0.86 Mach number. What is temperature deviation? So TAS is 900 knots. 0.86. 29,000. TAS Mach. It gives you calibrated airspeed, but it doesn't give you temperature value. Okay, no problem. So Mach number equals to true airspeed divided by local speed of sound. 0.86 equals to 500 divided by local speed of sound 39.17 square root of temperature. The square root of temperature equals to 500 divided by 0.86 into 39.17. 0.86 into 39.17 be 3.6862. Let's make it 34. 500. So 500 divided by 34 is 14.7, that is 50. So temperature equals to 225 Kelvin, or 225 minus 273 is minus 48 degree Celsius. Okay. ISA deviation, outside air temperature minus ISA temperature. Outside air temperature is minus 48. What is ISA temperature at flight level 290? 15 minus 2 into 29, that is 43, correct? So minus 43. Minus 48 plus 43 is minus 5 degree Celsius. So the closest option here is option alpha. Select that. 12. An increase of 0.15 in Mach number results in an increase of 93 knots TAS. If temperature deviation is plus 9, that means outside air temperature is warmer than ISA temperature by 9 degrees Celsius. What is the level? What level are you flying at? Local speed of sound will be equal to true airspeed divided by Mach number. True airspeed 93, Mach number 0.15, that is 620 knots. So 39.17 square root of temperature in Kelvin equals to 620. So this will be equal to 620 divided by 39.17, 15.8, that is 16. So temperature will be 16 square, right? So that is 250, approximately 250 Kelvin. 250 Kelvin minus 273 Kelvin is minus 23 degree Celsius. Okay? So minus 23 degrees Celsius. This is your outside air temperature. Now temperature deviation from ISA is plus 9. So ISA deviation equals to outside air temperature minus ISA temperature. What is deviation plus 9? Outside air temperature is minus 23 minus x. So x equals to minus 23 minus 9 is minus 32 degree Celsius. Now where do you find this minus 32 degree Celsius ISA temperature? So use this formula. ISA temperature equals to 15 minus 2 into pressure altitude 2x. So minus 32, 15 minus 2x. 2x equals to 15 plus 32, that is 47. So x equals to 47 divided by 2, 23.5 or 23,500 feet. Approximately, bravo, flight level 220. Okay, next. Aircraft is flying at flight level 390, temperature is minus 56.5, Mach number is given to you. What is TAS? 59,056, 56.5 minus 39,000 and Mach number is 0.85. True airspeed is 492.7. Okay. So 492.7. The closest value is option Charlie, 485. So select that. Next. An increase of 0.15 Mach is equal to an increase of true airspeed of 93 knots. What is the local speed of sound? So local speed of sound will be true airspeed divided by Mach number. So 93 divided by 0.15 is 620. Option Charlie. Last, increase of 0.15 results in 93 knots task increase. Temperature deviation is given to you. What is the flight level? So local speed of sound equals to true airspeed divided by Mach number. True airspeed is 93. Mach number is 0.15. 93 divided by 0.15 is 620. Now we all know local speed of sound equals to 39.17 square root of temperature in Kelvin. So temperature in Kelvin equals to 620 divided by 39.17 is 15.8 or 16. Squaring both the sides, answer will be 250 Kelvin. 250 Kelvin minus 273 is minus 23 degree Celsius. Okay. So outside air temperature is minus 23 degree Celsius. ISA deviation given in the question is plus 5, outside air temperature minus ISA temperature. So minus 23 minus x. So x equals to minus 23 minus 5 minus 28 degree Celsius. Now at what flight level do we find this ISA temperature of minus 28? Use the formula ISA temperature equals to 15 degrees Celsius minus 2 into pressure altitude. So minus 28 equals to 15 minus 2x. 2x equals to 15 plus 28, 43. So x equals to 43 divided by 2, 21.5, that is 21,500 feet. So 21,500 feet. Flight level 200, flight level 150, flight level 220, flight level 250. So it should be between option alpha and Charlie. Select option alpha, flight level 200. This concludes the lecture. I hope you have understood all the 15 questions I have answered in this video lecture. This is how you do questions of this type. These questions will definitely get asked in your DGCA NAV exam and MET exam. So ensure that you are familiar with the process, with the procedure involved in solving these questions, how to use CX-3. If you have any questions, let me know in the comment box. Thank you for your time. If you have enjoyed this lecture, please subscribe to this channel, share this video lecture with your friends, and hit the like button if you have liked this lecture. See you.